Sure. So I think it's the first session by Sudhanshu today. So maybe a little introduction of Sudhanshu first of all before we begin. So Sudhanshu basically is going to be your new instructor, and he's a 2017 IT KGP pass out. Post which he actually did his masters in computer science from UCSD, University of California, San Diego, and after which he's been working with Salesforce in Seattle. So yeah, whatever he's going to teach, he's actually has the expertise in all these domains. So and apart from that, he is well known for the intuition, for his intuitions of algorithms and data structures as well. So any question you can actually ping him anytime. Any type of question he can mostly solve them by intuition only. That's how we know them all in debugs. Sure, Sudhanshu, over to you then. I think you can start.
Okay, thanks for the introduction. So without further ado, let's start. So guys, I won't be able to look at chat all the time. So if you have any doubts, please unmute yourself and ask them. Okay. Just give me a minute. So let's start with database. A brief history about database initially, right? So in 1970, there was a challenge to create first relational database, which was won by Oracle. And like that challenge became pretty popular and pretty widely adopted throughout the tech industry. And that's when the traditional database management systems came into play. And that's how like Oracle became one of the big players in database, and all the big companies, even today, they use Oracle database to save their data, maintain their data, and things like that. So when I talk about database, like what comes into your mind first? Like, what do you think? What does database means? Like, can you guys unmute yourself and speak up? What is database according to you?
Collection of data.
Collection of data. Okay. Anything else? That's it. Anything else you guys think?
Related to each other somehow.
Related to it somehow. Okay. Related data.
Structured data.
Structured data. Okay.
Uh,
What else comes
sir,
in?
it is a manner, it is a structure in which we store data in the form of tables.
Structure in which we store data. Okay. Anything else? Is that it? Anybody wants to add something?
Server.
Operations.
Pardon?
We can perform operations.
Operations. Okay. What else?
Server.
Server. We save database in server. Okay. Is that it? Any like, come on guys, speak up. This is for your learning only, so it will help you just to create notion what is database and what is not. So what else do you think? What else comes into your mind?
Database is organized collection of data so that we can access and manage and update it accordingly.
Okay, so collection, it's there, related data is there, and do operations. So these 3 points. So I've written this down. Okay, so let's start. So database, essentially, the way I try to define it it is like, as you have correctly said, it's a collection of data, and it's not data, it's interrelated data, right? And one more thing that I would want to point out, it's model some real aspect of the world. So this is also critical, like you want to model something of the world. Say, suppose you have DBMS Academy, right? So data could be data for instructors, like what all instructors are teaching at DBMS Academy. The data for batches, what all batches run. Data for students, what all students are enrolled, right? So one in data for schedules, like what all schedules are present, so on and so forth. Like these are all, so these are interrelated data. It's a collection of data, and it is modeling some aspect of the world, which is DBMS Academy. So this is one example of a database, right? Now, few things, right? Data has to be structured. It is stored in tables. So this is also there, like, and you provide some operations and server. These are not actually database, but there are some softwares that provides you this all things. But database is just the base of the data where you save everything. That's it, right? So I guess this should be pretty clear to everyone, right? Now let's say that I want to write my own database, right? I said that it's just a collection of data, so I can, in the raw form, right? I don't have any database like SQL or things like that. Like completely remove those things from your mind. Let's say I want to save my database in raw form. What I do, for example, for DMux only. So I want to create 3 databases. One is for instructor. One I want to save database for, say, batches, right? And I want to save, wait a minute. I want to save database for schedules, right? So instructor, and say in raw form, when I'm trying to save database, a very basic way is to save in CSV file. So if anyone does not know CSV file, it's a comma separated value file. So it has a header and all the data are stored in comma separated values. So instructor name, say I save data like I1, like some instructor ID, the name of the instructor, say Sanket, right? And his email, like s@dmux.in, right? I2, say it's Varun, and his email like v@same dmux.in. I3, like it's my name, and I don't have a DMux account, so I have my own account. So on and so forth. Say I have some account, right? Now there can be batches data. So the batch data could be like B1 batch ID, say DSP1, and number of students, say 49, right? Then there is another data B2, and these are all comma separated values that you have stored, DSP2, and say 91, 99, let's say. Then you have B3, you have DSP3, and you have 35, just for example. And then you have data for schedules. So I can say that instructor 1 will take batch 1, right, on some date, let's say 0304. Instructor 2 will take batch 2, say on some other date, 03, on the same date, right? And then there can be instructor 1 will take batch 3, again on 0305, right? So say I have all these data that I have written in CSV format. Now there are a couple of queries that I need to perform, right? So one query could be like get all the schedules, right? All the schedules for 0304, let's say. And I want to write a Python code for it, right? Or you can write a C++ or a code in any program fashion. So how would you do it? Like a very simple way to go about doing it is to write a loop, like open this file and read everything, right? So this is pretty simple. So you will, let's say if I write in Python, I will say with open schedules as if you do like for line in f dot read line, then you just check, then there will be some checks going on over here and you will read the data like select I comma b is equal to line of 0 to 1, I guess, right? And then you do print ib, and that's how you do it. So that it's a pretty simple way. Now let's say you want to insert something in the schedule. Like a new schedule has come up and you want to insert a new value in schedule, let's say I3 B1 and 0304, right? So a very similar code path will follow and you will insert this value, right? So there are some checks that you need to perform, right? Like, and there could be some issues while you're doing operations just on comma separated values. Like, do you find any issues? Like, what all issues can arise? Like when the number of instructor files will grow, batches will grow, schedules will grow. What checks or what things do we need to take care of while performing insertions, deletions, or updates?
Like, sir, we have to, if we remove the instructor 3, then we have to remove all the schedules by the instructor 3. Like if we have to check that instructor already exists in the instructor table or not before we insert into the schedule.
Yes. So check for instructor before removing, right? Anything else?
Sir, one instructor cannot have like more than one classes on the same day.
Okay. That's good. Anything else? So it's a very simple algorithm question that I am asking you. Like, so what else do you think?
Instructor should not have same email ID.
Exactly. Okay. What else?
Similarly for instructor codes, like instructor code and the name should be different. Like a same code should not be given to two person, or one person should not have multiple codes.
Okay. Anything else? This is good, guys. Like, I think you are thinking in the right direction. What else? Like, in terms of programming, do you find any difficulty?
It would take a lot of time, I guess.
Okay. So implementation is tough.
I mean,
Okay.
even for the simplest, even for the simplest task, we'll have to go through, like iterate linearly.
Yes. So time complexity, it's like, it's not optimal complexity that we want. What else? Like anything else comes into your mind?
There is no standard way to represent binary data.
No standardization. Okay. Is that it?
Like sir,
Anybody want?
check
Pardon?
on check on the
Full support of
length
special
of values.
characters also.
No support for special characters. What you said? Checks you need to perform.
I'm saying sir, check for the maximum length of the keyword. Like the name cannot be exceed like 30 words,
Yes.
30 characters.
So basically, basic checks you need to sanity checks, right?
Sir,
Okay. There is no standardization. Then there are supports for special characters not performed. Okay. Anything else? Do you guys feel it's not present? So let's come to the issue. I guess the issues that you have highlighted is pretty much sufficient. Like it's good. Like just to summarize, like all these tables, you think whenever you think of a database or real world systems, think of it. Everything is dynamic and things can change any point in time. If you say if you have your own company and there is some assistant and they are inputting values in CSV file, things can go wrong, right? They can misspell some things, or somebody like said that instruction code, the instructor code, it has to be unique, it cannot be same. So some, like there are billions of lines of code, somebody wrote 1416 somewhere, and in later like someone else while editing they also wrote 416, then there will be a conflict. So checks like this, it's very difficult to perform checks like this, right? And let's say in date, like you for date you have a specific format, like I would provide month and then day, let's say that's the format that I'm using over here. Like somebody edits it and he writes like DDMM, so he will write 3112, things like that, and this will throw an error in your code while you're executing code. These are those checks that are performed. Also, you see, like whenever you're trying to implement, you need to write a lot of checks, so it's not easy. And every time you have a new table or a new CSV file, you will have to make. Uh, am I audible to everyone? Like, is my sound clear?
yes sir.
Okay.
Yes, sir.
So Ritik, I think it could be connection issue on your front, on your side, some internet issue. So yes, so there are those aspects, and implementation, it's not easy. You will have billions of lines of code when the systems will grow. There is, somebody said that there are no standardized, there is no standard or specific way to implement this. So today you have written like beautiful lines of code in Python to do all checks and everything for Demux Academy. Next day some other academy comes, or there is some other version of Demux that turns up, then you again you have to write same versions of code because the requirement may be different. So one more thing, like to deal with very high level is, suppose you are working on an internet, right? Or multiple users are modifying the same file. And like they say there is a user one, they are modifying line number 3. And then again there is a user 2, which is also modifying line number 3. How will you ensure that which version will take place? Or how will you make sure that the most updated version is reflected over here? User 1 can modify old value, and while user 2 is modifying to a new value. So that issue is there, right? Another thing is, like while you are like there are a lot of things that you're updating. Let's say you updated line 1, line 2, line 3, line 4, and you have multiple lines that are updated, and before you hit save the system crashes. So how sure are you like what all data went through and what all data did not went through? So those are another issues that comes into play. So I think that this is a pretty sufficient intuition or motivation, like why do we need, like why the normal way that we save in CSV file won't work. Is there any doubt till here, like anything you did not understand? Like guys, can you speak up? So I can know like
Clear, sir.
Okay, is this clear, right?
Yes,
So
sir.
this,
Yes, sir. Clear.
Clear, sir.
so this gives us what did was like, this is how the entire theory evolved, right? And then we came up with the concept of DBMS. Now DBMS, it is called database management system or database management software, whatever you want to call, right? And DBMS, it's an abstraction on top of your DB, right? Which provides you all the issues that we were facing in the first place. So the way we define DBMS, it is used to store your data. It is used to analyze your data, right? And without worrying about the underlying detail. So it provides you both of this without worrying of underlying detail. So this is what the entire DBMS is for. And one more thing, since it's a software or it's a system, it is a reusable software or a system. So this is also critical. So right now you don't want to have a separate lines, like separate files or separate codes for demugs, separate codes for your university. So you can use same software over and over again, and that is sufficient. So the entire course that we are going to talk about, it will be based on database management softwares. So we generally tend to use this term very loosely, like this is a class on database, but actually the entire class is on database management systems or softwares, which is essentially, it is used to hide the low level details, like all the level details that we have, and it tries to provide an abstraction like how the data is stored and things like that. Let's go back to the original point that you were saying. So in database, remember that you were saying that it is stored in tables and you do operations, or it's a server. These or it's a structured. These all of these are parts of database management softwares. Only database, by database only means it's a database, right? Collection of data which models aspects of the world. Other things are the guarantees or insurances that is provided by database management softwares, right? So I guess till this part, the notion of database and database management software is clear to everyone, right? If you have any issues, please speak up.
So what do you mean by analyze the data while defining DBMS?
So remember over here we had one option, get all the schedules for 30304, right? So this is one way of analyzing the data, right? Or you can say that how many instructors are there who are working from India. So that's another way of analyzing the data. Another way could be how many instructors are there working from India who have classes on 0304, right? So there are complex analysis or operations that you can do. Any other doubts that you have till now? Guys, can you give me an ACK or no ACK?
Clear, sir.
Clear?
Yes, sir.
Everything? Okay. So now in the journey that we have doing, like we are trying to build our own database management software or systems. Now it comes to the part that we need to store data, analyze data, right? So when we say we want to store data, we have to provide some kind of abstraction to the user, right? So for the user, it should be a single pin. Let's say that there is a user over here, right? He's interacting with the software, DBMS over here. So this is your DBMS. And then there is a memory or system over here, database, where it is actually saving the data for you, right? Now, how it is doing all the operations, it doesn't matter, but the DBMS should give you an abstract view, like how the data is being saved or not saved. So it gives you an abstract view of the data. Now these abstract view, it's like someone pointed out, it can be in forms of tables, right? So one abstraction view will be like just there is a table, right? Table has a header like instructor ID, name, and email. There is one table like this. So when you type in some command in your shell like dash show tables, so in the underlying implement we don't know how they are showing it, but it is giving some abstraction. Okay, this is what your table is. One is table for instructor, right? Similarly, there are tables for courses, let's say, and then there over here you can have course ID, you can have name, you can have tables for students and batches, so on and so forth. There are multiple tables. When you enter hit show tables, it shows you all the tables that it is present over here. So there is some kind of abstraction. So there are many ways to provide this abstraction. One is called relational model. So in relational model, the idea is very similar to that. We model everything in forms of tables. Another way to provide this abstraction is using key value pair. Another way is to use documents. You provide abstraction in terms of documents. Today's like in machine learning, they provide abstractions in form of arrays and things like that. There are Facebook, they use some abstraction for graphs, like they visualize their database in forms of graphs. So these three part, where key value, document, and graph, they are also called NoSQL. And when we use relational model, we say it's SQL like query, SQL like database. So today, like in our lecture, we will only be focusing on relational model, right? So that is the abstraction that we are going to define. Now, when we say, okay, we are going to define relational model as an abstraction, what do you mean by relational model? What exactly does it mean? So if you have any doubt, like please pause me anytime and we can clear it out there and themselves. So in relational model, we say that your tables define the relations. So similar to the one I showed you in the previous slide. So like this table defines the relation for instructor. There's a course that defines the relation for course. Then there are schedules that defines relation between instructor and course, so on and so forth, right? Rishabh, I guess this will be recorded and then you can look into it. If you have any doubt, we can clarify it over here. Okay. So like, don't focus on taking notes. Like this will be recorded, this will be provided to you. Just try to question everything, and that's how like it will benefit both of you. Like it will benefit me as well because I'll also get to know something, and it will benefit you as well. Okay. So over here we say a relational model. There are tables that defines the relation, and that's the abstraction we are providing to the customers or to the end users, right? And the data is stored in simple data structures. So when you're trying to implement a relational database, we say that database is saved in simple data structure. An example would be like in C, you have a struct data structure, right? So anytime a user creates a table, like say user is creating an instructor table, then there will be struct instructor. and then they can also specify like say int id string name string email. So in the low lying implementation, this is how it's being stored and fetched. Then we have like high level language to access the data, to access / update the data. So okay, sorry. So the analogy over here, high level language, it's very similar to compilers. So what does compiler do? You have a machine and you provide a high level language to compiler, and compiler is responsible to convert it into machine level language, which then the computer understands and it performs operation on it, right? So compiler provides an abstraction of high level. Similarly, the relational model databases, they will provide you a high level language that they can understand, and then they can interpret the language in their own fashion, and they can access or update the data or perform operations how it's being done, right? Is this clear? Like the analogy is very similar to that of compiler, right? And then the physical storage is left to how the database is physical stored. Physical storage is left to DBMS. Users have no role in it. Right? Is that clear? So this is done, and oh shoot, I'm sorry. 1 minute, guys. My screen locked out. Physical storage is left to DBMS, and then there is clean separation between logical layers and physical layer. So that's it. So these are, can you repeat the last one, physical storage? Sure. So physical storage, like how, think of it, a database management software as a huge piece of code that you're writing. So over here, you're writing a code, right? You're writing a Python file, which is getting all the schedules, inserting and things like that. So think of this as your DBMS, database management system, and whatever queries the end user is making, one of the functions is getting hit. Now your Python software, you can decide how do you want to save your data. You can save it in pickle format or some other format. By default, it was saved in CSV format. You can just dump the entire object in some specific way that you want to do. You can divide the data and you want to store it, right? So say that the schedules, it is getting very big. It cannot fit in one file. So what you do, you divide schedules into mini files, and then you have a folder for schedules, and then you have multiple files in that schedules. So how exactly the data is being stored, it's not a concern of the user, but it's concern like how database is handling it. Is that clear? Did that make sense? Okay, cool. And then clean separation between logical and physical layers. This idea, it comes from the above idea itself, right? So
Sir, I have a doubt.
yeah, go ahead.
So let's say you ask a query like sum of a column or something. Will the function in the Python code sum get hit over there? Like, is that what's happening?
Yeah, that is exactly what is happening.
Okay. Like, how does it get to know that it has to execute that function? Like some mapping.
So There are abstractions, right? So they provide like by default. There are some abstractions given, like they won't provide you with all the functions, but they will provide you like very strict function like sum or max or min or average,
Yeah.
right? So there are some standard functions that the database is providing to you, and those are only standard functions DBMS is providing to you, and those are the only standard functions that you can use.
What if you want to add some new functions? Like, how can I do that?
Then you need to create your own DBMS because that is not supported
Can't
by.
add it to the existing one.
Pardon?
We can't add it to the existing one.
Cannot, not that I know of. That's a good question, but I don't think you can add to an existing one. I'm so
But
there are other ways. Like a way to do it is you can define your high level functions, but ultimately you need to use their operations to get to your functions. You cannot directly add it. Like you just can't have just one line of like percentile. So I guess they don't provide you a feature for percentile. So you can have a function, like you can define a function of percentile within DBMS using DBMS language that they provide. And then you can call that percentile function, but you cannot add it. Like for like you being the user, you cannot add it. Like in the low level design.
where do we add this percentile function? In the Python code or?
Not in the Python code. So Python code will provide you some abstraction, right?
Can you like draw a visual representation from lower level to high level? Like,
okay. So say you have bunch of the analogy is pretty similar to compiler or like any coding language, right? So you have say you have DBMS over here, right? And DBMS by default it is providing you with these functions: max, min, sum, average. Let's say these four functions are there, right? And inside DBMS there's a file called max.py or compute max, and then there are file like compute min.py, and there are a lot of functions over here, compute average.py, right? Now whenever you call this function, it hits one of these values, right? Max will hit max, min will hit min, average will hit average. And then database also, like the database that we are going to study, you can define your own like function, like say myfunc, right? You can define your own function over here and you can say what your function can do. So even in myfunc, when you like use the language for DBMS that they have provided, you can do max.
Okay, you can only use the function already there to combine it in some new way.
Yes. So now you can use myfunc, but essentially you are using the max and sum only. You're not doing anything else, right?
Yeah, got it. Yeah.
So like the raw functionality you cannot append, not that I know of, right? So that is there. Is this clear to everyone? What his doubt was? Any other doubt? Any other questions? Guys, act, no act, so I can understand.
Clear, sir.
Okay.
Sir, when we are creating our own functions, is it necessary to use some combination of the existing raw functions, or can we define our new function which does entirely something else?
How will you define it? Like, so you're saying you're using Python, right? So you're using Python programming language. So essentially you need to use the for loop, the way the for loop the Python has given you, right? You cannot define a new way to define your for loop. For that also you need to use the Python program in the end, right? The functionality that Python programs gives you. So Python is implemented on top of C++. So what you're asking is, can I change the C++ code? And I'm saying that Python is your, so let's draw an analogy over here. So you have Python, it's built on top of C++, right? And then it's in assembly, right? So essentially, when we have DBMS provides you with some functionality, and they can be built on their own language. Say it's also built on C++, and then which again converts into assembly language. Now in Python, you write some functions, some scripts, whatever operations do you do. If you want to have you have some function that you use repeatedly, then you write that function let's say there's a function f1, and f1 is being called every time. So you write your own function f1, and anywhere in code you just call f1 to get your output, right? X equal to f1. That's what you do in Python. If it gets used multiple times. Similarly, but you cannot change the C++ code to have a function f1. Actually, you are writing that in Python only. So in DBMS as well, the way we do it is we use all the underlying functions or the what do you call operators that DBMS is giving, and you can write functions on top of these operators. But you cannot just go and write in. Well, you can go like there are libraries like MySQL. It's open source. You can go, you can fork it, and you can change the C++ code so that is represented over here. But like that will defeat the entire purpose of having DBMS in the first place, right? Because it is there to provide you some kind of abstraction. Is this clear to everyone? Okay. Okay, good. So this is there. So guys, I'm not following the chat that frequent, so I might miss some notes. Let's come back to our original topic. So this is a good segue. So you're providing C++, you have Python, you have DBMS. Now the abstraction that you can do, there are many ways to do this abstraction. One is to do a relational abstraction, the way we are talking about. Another way will be key value, document, the things that we talked about, right? So if you're doing a relational abstraction, then you have to, these are the operation that is present. If you're doing key value, document, or other abstraction, then there are other values that. So think of it is like multiple programming language. Relational is like Java, then key value will be like Python, document will be like Scala, so on and so forth. So underlying implementation behavior, everything is different. But you can pick and choose any operation, any DBMS you want based on the requirements that you have, right? So this is the relational model, like that we said that the table defines the relation. There are simple data structures that they use to store, and then they give you a high level language, like the way we talked about over here. They have given you high level language to access and update the data, and then physical storage is left to the DBMS. That doubt is also cleared, and then there is clean separation between logical layers and physical layers, right? So this is the physical layer and this is the logical layer. So in logical layer, you're just calling one operation max. Max in turn is calling compute max. Compute max is then interacting with your OS, and it is saving the data, right? So relational model says that this is how my model will look like, and what are the guarantees that I'm going to give. So it gives you some kind of guarantees as well. Like why would you want to use a relational model in the first place, right? So it gives you some kind of structural guarantee, like it will provide you some kind of structure to save your data. Then it gives you integrity over your data. We will talk about this in more detail, like, and then it gives you like manipulation of your data. These are all these actually I should not say guarantees, I should say functionalities. What are functionalities it gives? So it gives you structure functionality, it gives you integrity as a functionality, and you can manipulate your data. So I guess this is pretty much common in all the databases. It's not specific to a relational database, right? So we will come to this in a bit. I guess this is pretty trivial. Now let's go into some details, right? So what we discussed right now, that data will be stored in form of tables, which has a meaning of relation, right? So let's talk about what do you mean by relations. We will go through some technical terms, right now. So over here we are looking at structural functionalities, right? So what do you mean by relations? Anyone you want to speak up? Like, so we say that we are going to use tables to save the data, right? And which will model some aspect of relations. So and this is, we are also calling it relational model. So what do you think will be relation? What comes into your mind, guys?
So some way to compare the
Some way to what?
some way to compare the data.
Mapping between two sets.
This is what I heard.
Also, we can say that the basic unit that will hold the data should should display some kind of a relation among the data.
Okay. Mapping between two sets. Basic unit to store data. What do you mean by mapping between two sets? Can you elaborate? So somebody said mapping between two sets, right? Or did I overheard?
Yeah. Mapping basically means the columns, how are they relating to each other, or like the sets, if we say.
Okay. Okay, so you have a table and then column names. Then how are column names related to each other, right?
Yes. Or
Okay.
two different tables, how are they related to each other? Basically,
I
how are
see.
two sets related to each other?
Okay, so you're calling this as set one and another as set two, and it has their own column, right?
Yes.
And how they are related. Okay, anything else?
It's a characteristics of an real world entity.
Characteristics of real world entity, but that is like database itself, right? Like what is specific to relations?
Like sir,
But it's I
if a
guess it,
person has name, he has some the person has some
yes.
features that defines himself.
Okay. Yeah, I guess that's true in general. Sure. Anything else? Any guy, like anyone of you want to add something, or is that it?
So you can even compare like different tables and see how they're related to each other.
Yes, so I think this is covered in the second point, mapping between two sets. So he's saying that there are two sets, you can assume it to tables. So what he's saying is tables and sets go hand in hand, and then you can do some kind of relations between two things. Anything else?
So some column in the first data set which allows you to associate with some other column in your other table. Something common basically.
Okay. So constraints so let's say instructor, and so instructor has instructor ID, course has course ID. So this will have instructor ID, course ID, some schedule. So columns related, I will add that. Anything else?
So we can find some correlation between the data so that when we add a new data point, it will automatically add the values.
Okay. Anything else? Is that it? Okay, let's start. So there are some truth to all of the things that you have said, which is good. So you are getting what it's there. So relation, it's unordered set of attributes that defines instances of entities in a database, right? So it's a very high level or abstract way. Like when think about it, like we're doing some kind of mathematical modeling or mathematical concepts. So it says that it's an ordered set of attributes. Unordered set of what? Of attributes, right? And it is saying that all the entities or all the entries will be an instance of this. See, all the entities in our database will have an instance of this set of attributes. Was there any question? Anyone repeat the question? I had connection problem. So which question? So we were discussing about relations. What do you think relation is to you when it comes into your mind? And like there were a few suggestions that we had, and then we went into the formal definition, like what are relations. So like everything will encompass in these three settings. So when we say unordered set, right? Okay. So when we say unordered set, so let's say we take an example of instructor, right? Let's say, what do you mean by attributes? So instructor, it will have some attributes, right? What are the attributes? It will have an ID, it will have a name, it will have phone number, it will have address, it will have email, right? So these are all the attributes for instructor. And it is say it's an unordered set. So ordering is not important. Like phone number can go behind, address can come first. But once you fix the ordering, that's the way the data should be. So all the entities, like what do you mean by entities? So it is saying, okay, you have an instructor table, very good. Now my instructor table will look like this. That's what you're specifying in the database. This is the way my instructor table will look. And all the entries in the instructor table will have this instance. So this is one instance, say ID one, like instructor one, right? Say Arun is the name. He has phone number 9180 something, so on and so forth. Some address and Arun at DMux, right? So this is an instance, right? This is a single instance, and it is so when we are inputting this value in our database in the instructor table, it follows the paradigm that we have defined above, right? So the attributes that we have defined above, the entries will form in that attributes only. So all the entries, when I say, okay, so a good way to think about it is when I say that this is the definition of instructor, right? When I say this, then the natural thought process will come into your mind. Okay, there is an instructor table which are an ID, name, phone number, address, email, and all the entries in the instructor table will follow this pattern only. That's it. So that is how we define a relation, right? So there is a relation from instructor to one set of attributes, right? Similarly, there could be relation for student, right? And it can let's not talk about student. Let's take a good example. Let's say batches. So there's a relation from batches, and then it will have batch ID, batch name, and number of students. So then there is another relation from batches to batch ID, batch name, batch students, and all the entries will follow this pattern, all the entities, right? Now there could be schedules. Schedules will have another relation, which kind of batch ID, instructor ID, and date. That is the third relation that we can have, right? So I guess this is clear to everyone. If anything is not clear, let me know. So this is a structural aspect that we are, yep. Go ahead. So I heard someone speaking. Is there any doubt? Okay, so let's move on. Please guys stop me if you are not following or you're not understanding something.
So what are the three features of relation?
Relations.
Yeah.
So we say it's an ordered set of attributes, right?
Yeah.
And so these are the attributes, right?
Yeah.
And it's a set of these attributes. So
Okay. Yeah.
and like the ordering is not important. Name can go in the last, email can come first,
Yeah.
ID can be in the middle. So the ordering is not important, but we say that all the entities, like all the entries in the instructor table will follow this instance, like will follow this, the above attribute. Is it clear to everyone? Guys, can you act, knack?
Clear, sir.
Okay. So sometimes like when I don't get a response from you guys, so I think I'm not teaching well, or I'm just talking and like no one is getting it. So it's essential for you guys to reply so that I can fine tune my pace according to that way. Right now, let's come to the concept of primary key. Right. So now over here we are talking about the integrity part, the functionality for integrity. Right. So what does primary key says is from the definition it's a primary and it's a key, right? So if you have this thing, then you can unlock everything. Think of it in that way. And it's a primary, so it's a unique thing. So the way we define it is uh, we define it in terms of relations, right? So if you have a relation and the columns are C1, C2, C3, so on and so forth, say Cn, these are the column in my relation R, right? So we say primary key, like it's a subset of these attributes. Let's say C1 till C3, it's a subset of these attributes that uniquely defines the relation, right? Or that uniquely identifies a tuple, right? Or entities. So one more quick jargon, entities and tuples, I will use like either way, right? So I will say that this is an entity, this is also a tuple, so on and so forth. It's a quick note that we have. So it's a primary key, it's a subset of attribute, and any tuple with if you pick that subset on any tuple, right, then it will uniquely define all the other values for all the other attributes for that tuple. Does that make sense? So in the
So could you explain keys again? The
Keys
primary
again?
key. Primary key, sir. Could you explain it again?
Okay, I will just write it down. So it is subset of attributes which uniquely identifies a tuple. right? So when I say subset, you have a lot of things in attributes. So there's a subset of attributes, right? So let's say if you fix those subsets, then any tuple you pick, so it will have entry 1, entry 2, right? So what I'm saying is, let's pick an example, say instructor example, or do you want to pick any other? Let's say, what do you call batches? You have a relation for batches. So you have batch ID, you have batch name, and you have number of students, right? So entries will be B1, DSP1, number of students is 49, B2, DSP2, student is 49, and then there will be 3, DSP3 is 81, say, right? So when I say, hey, did anyone had any question? Okay. So when I say B1, right? If I say B1, so I'm saying over here that BID is the primary key, right? Because when I say I'm dealing with batch B1, then you know for sure batch B1 corresponds to DSP1, which has student number 29, right? But if I'm saying that I'm dealing with student, right? The number of student is 49. So you don't know which tuple I'm talking about, whether I'm talking about the first tuple or I'm talking about the second tuple. But if I specify the batch ID, then you know that, okay, I'm talking about this specific tuple only. If I say B2, I'm talking about this specific tuple only. There could be case where like when these things grows, right? They can be like batch 25. It can also, the name could be DSP1. It could be possible. And students could be like something for 81 as well.
Clear, sir. Understood.
So this is, so it's a subset of attributes. So what are your attributes over here? These three are your attributes, right? These three are your attributes, and subset is this one is a subset, right? So it's a subset of attributes which uniquely identifies your tuple, right?
So,
Pardon? Yeah.
so can we have more than one key also? Like we can
We can
consider
have.
in certain cases we can have more than one key as well.
In certain cases, we can have more than one key. That's correct.
Okay, sir.
Right.
Clear, sir. Thank you.
Okay.
So basically the attribute whose column has only unique values and no repeating values, right?
Yes. Yes. That comes from the inference, right? So if it has repeating values, it cannot uniquely identify a tuple. Does that make sense? So this was a critical thing that someone said. Did it make sense to everyone? Okay.
Yes, sir.
Nice. So
BID is the primary key, right?
what? BID is the primary key. So
Okay.
suppose let's think about population as another table, right? The global population. So it will have city, it will have country, it will have population size. So what is the primary key in this case? Can anybody?
City.
City and country.
Okay, somebody said city and city. Somebody said city and country. Why did you say city?
So because a country can have more than one city, and city, like the populations can also be common in some of the cities.
Yes. So a tuple will be a primary. A subset is city and country, right? Which is a primary key. Because let's say was city, right? There could be a city name. What do you call? There's some no common city name. New York, let's say. So or let's we have India, right? So we can take Hyderabad. Hyderabad is present in Pakistan, if you guys know, and Hyderabad is present in India. right? So only the city cannot uniquely identify this tuple, and population for this could be 4.1 m, and population for this could be 8.2 m. So Hyderabad cannot uniquely identify the tuple, but the city, country can uniquely identify. Okay, if you give me Hyderabad for Pakistan, I can say that okay, it has population of this, and population. There could be other thing, population density, other factors also. It depends on the tuple. So that's why the subset of attributes is essential, right? Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, cool. So primary key is good. Now the other part of integrity is foreign key. Right? As the name suggests, foreign key, so it's not in the table, but it's on some other table, right? Because it's foreign. This also comes under integrity section, right? So what foreign key states is that it's an at. What do you guys think? What should be a foreign key? Let's first discuss this. So remember, there was somebody pointed out columns related between tables, right? So you have some column in one table and some column in another table, or mapping between two sets. So foreign key are essential. The foreign key has these essential properties. So what do you guys think? What is foreign key? So primary key, let's say primary key, we say it's a unique, right? So from key, we know that it should be unique. And foreign key, we are saying for foreign, so it should not be in our table, but it should be in another table. Any thoughts, or should I proceed?
Yes, sir. Yes, sir. Like the BID
Yeah.
works as a foreign key in the schedule table because
Yes.
we are referencing the batches from some other where we stored the number of like the uh,
Yeah.
features of the batch anywhere.
Yeah. So that's a good point. That's exactly what's the premise is. Anybody wants to add anything? Okay. So foreign key, we say that like the official definition of the standard definition we have, it's attribute or subset of attribute, I would say. Subset of attribute. It's a subset of attribute in one relation has to exist in at least one of the tuple in another relation. Should exist as tuple. I'm calling it should exist as tuple, right? In another relation. So coming to that example, it's a very classic example. So instructor. So it has instructor ID, name, so on and so forth. I won't write all the things. Then you have batch. You have batch ID, name, so on and so forth. And then you have schedules, right? Now schedules will have instructor ID as one of the column, batch ID as another column, and date as the third column, right? So it is saying that subset of attributes in one relation that should exist as a tuple in another relation. So over here there is an instructor ID, right? So when I write instructor 5 over here, and like over here it's only I1, I2, and I3. Now this does not make sense. Like, what do you mean by instructor 5? So there is no integrity guarantee over here. What I say is in schedules that IID, this is a foreign key for the instructor table. So what I will say over here is it is a foreign key on instructor table. instructor ID. Similarly for batch ID, I will say it's a foreign key on batch table. Batch B ID. This will be IID. So what it says is any entry in this there should be at least one entry which has the same value. So if I5 is not present over here, it will reject this entry. Okay, if this entry is false, it's not there. Or say I3 is there, but B5 is not there, it will reject this entry because the constraint on foreign key is violated. Is this only? It will only accept those entries for which something is already present. So say B1, B2, B3 is present. Then in foreign key you can add I1 and B1 because it's present in both. You can add I2 and B2, I2 and B1. You can add I3 and B2, so on and so forth. Because everything is present as part of these they exist as a tuple in another relation. So B1 exists as a tuple in another relation. B2 exists as a tuple in another relation. Like, pardon my handwriting, I butchered it, but you guys get the idea, right? Any doubt in foreign key, like anything that's not obvious?
What is the implication of having a foreign key? Like, why do we need this?
Let's go back to the original example, right? Over here, right? So someone is adding two schedules, and somehow it adds I5 over here and B13. Now I5 and B13 does not exist. So how can you add it in a schedule table? That should throw an error, right?
Okay.
It's not about printing data together, Karan. It's about maintaining the integrity. So if I'm saying that instructor is a foreign key and batch is also a foreign key on the batch table, then one of the entries should have this value if I'm adding this value over here. So it maintains the integrity of the entire thing.
So, but for the instruction key is the primary key for that table, right?
Yeah. So
for the schedule table.
No, instruction ID is not the primary key. Please, guys, don't write.
Okay. Sorry. Yeah, my bad.
Yeah. Instructor ID and batch ID is the primary key.
Okay.
Okay.
But so how are we defining this foreign key? Like so we're just saying that this is a foreign key, or what exactly is happening?
We are just saying that this is the foreign key. Like, this is a foreign key. So that's how we are defining foreign key over here. So we are saying instructor ID is foreign key on the instructor ID table, in the instructor table and IID attribute. And batch ID is a foreign key on batch table and BID attribute. That's how we are defining. So we are saying that anything that you insert over here, any entity or any tuple that you insert over here, right? There should be an existing tuple in the batch table, BID. Okay.
Yeah.
Any other doubts related to foreign key?
Why did you cross mark there near I5?
Because I5 does not exist over here, right? So foreign key constraint says that it should exist. That's the constraint over here. Should exist as a tuple in another relation on which you are saying. Any other doubt? So I guess we have confusion. Yeah.
So we can say that a foreign key should be primary key in other tuple.
Why do you say that?
So because it's not a primary key and there is a repetition of data. A primary key is defined because there is no repetition, right? So foreign key should be also defined without any repetition.
So what's the issue? Like, even if there is a repetition of data, why it can't be foreign key?
Oh, okay, sir, I got it. Right. It can be.
Okay, it can be foreign key. Any other doubt? Is it clear to everyone? Okay. So this is a complicated topic, like people do get confused in foreign key. So if you have doubt, please let me know. We can come back to it again if you guys want, right? Now we will talk about the third thing, the manipulation part, the functionality that it gives, the third functionality. So the way we can do manipulation, by manipulation, I won't ask what does it mean, because it's pretty simple. You want to manipulate your data, so you want to store, update, retrieve. That's what it means by manipulation. So it's pretty simple. Let's take a segue, and we say that in general, like there are two ways we do manipulation of data, right? One is procedural, and one is non-procedural. So in procedural, what I say, like you define a procedure, how you want to retrieve or update your data. Define procedure for manipulation. Right? Or you define a strategy. Procedure, you can also say strategy. So say that, let's go back to this, I won't write everything again. So let's say that we want to get all schedules for 0304. So the procedure will be like select anything from the schedules tables where the date is 0304. So you are saying a procedure. You go to procedure table, you scan all the rows, and wherever you find 0304, you select that, right? Or another is insert into the in the schedule this thing, right? So you say that go to the schedule table, insert this thing, providing that all the constraints are satisfied. So these are the, like, that is what we call procedures. Like you define the actual procedures. We will come to this much in detail how we do it. And then there is something other called non-procedural. So it specifies what data is required, but not the actual procedure. So you just say that I want data for instructor table, or that's it. Like, so we won't deal into this because I also don't know it in the first place, but yeah, there are other ways to do it. And over here, the way we define procedure, we will do it with relational algebra. This one also introduces like relational calculus and query optimization. So it's very high level. Like those who guys do PhD, they might know it, but like I don't have a PhD in DBMS. So the way we do it over here is using algebra or relational algebra, right? So the procedure, we define just a procedure how manipulating or retrieving the data. So this is good, right? Any doubts till here? Okay. So we will start with here. Nice. We will start with the relational algebra. Before that, let's do a quick hands-on on database. Like I guess it's getting too much theoretical right now. We will don't freak out. Like there are something like SQL that I have not taught, but I guess this is a good time that we can look at primary key, foreign key, and relations, right? So let's do that for now. So guys, you can also do some hands-on. 1 minute. Okay. Share. So you guys can see my screen, right?
Yes, sir.
Yes, sir.
Okay. I don't know if I can zoom in. Okay. So this is good. So we will use SQLite 3, and let's say I'm using a database dsp1.db, right? So that's the way. Now the way you can do is you can do dot tables, and you can see all the tables that you have. So right now we don't have any tables, so nothing is shown. Now let's say we want to define a relation, right? How do we define a relation? We just create a table. So relation and table, they go hand in hand. So let's say we create table R and we say A. So A is an attribute, first attribute. What's the data type? We say A is a varchar. We define another relation B, and we say B is also a varchar, right? And that's it. So that's how we define the relation. And then you do the dot table. You say, okay, R is a table over here. You can also see the schema for our, like what all attributes are there and how the table is defined. So you do the schema for. So the official definition of schema is, I did not go over the definition of schema, but the definition of schema is like how the definition of your like what actual data we are storing. So like it's A and B, both of them are varchar. Now you can insert. So these are like reserved keywords: create table, varchar, right, and insert table. But I guess these are pretty simple to understand. Like, and so I say insert into our values. So since it's a varchar, I need to specify A and B, right? So we can insert. Now a way to look at it is select. You do select star. We will come to all of this later, but like you can also learn now. So this is a procedure language. So I'm saying that select star means select everything from the table R, right? That's it. So I'm saying this is the procedure that I'm defining. Select star from R. So okay, let's do this. So you see, okay, A1 and B1 is present, like select everything from R. Now you can also insert other things, like you can insert multiple values. So I can insert A2, B1, multiple values together, right? A2, B2, right? So remember that A is not my primary key, so I can, or neither is B, so I can insert multiple values of same thing. So A3, B1, A3, B2, and A3, B3, right? So I've inserted everything. You do select star from R, and you see, okay, all my entities is there, is inserted. So insert into R. So you see everything is there. Values. I need a answer for this. So what do you think? Will this work or it won't work, or what will happen when I run this query? Oh, my computer is frozen. What do you think will happen when I run this query?
So it will insert.
It will insert. So A1 and B1 is already there.
Yeah, I just tried it.
Oh, you tried it? Okay, please don't try it. Just like.
Sir, I guess it will insert the values because we haven't defined what shall be the uniqueness about the attributes, like what shall be, I mean, what shall constitute.
Yeah. Yeah, so it will insert everything. So if you have tried it, that's fine. So you see that A1 and B1 is there over here, and A1 and B1 is also there over here. So it inserts the value. So when think of your tables as a bag, and you can have multiple and you are adding objects in your bag. So you can have multiple objects of same kind in your bag. So when you insert something in your bag, if original object is present and you insert a new object in a bag, two objects will be present. So it's not a set, it's a bag, right? So that's how the tables are defined over here. So it inserts multiple things over here. We can similarly create another table. So let's say I want to create a table with primary key. How do we do that? Create table R A varchar B varchar, and then I just say primary key, and I say okay A. So R is defined. So I need to call it something else. Let's call it R1. So that's how my primary. Now you can see the schema for R1. So you see, okay, A is a primary key. Now when I do insert into R1 value A1 B1, this works. But if I do insert into R1 value A1 B2, this will throw an error because primary you have unique constraint field. So primary key should always be unique, right? That comes from the inference of primary key because it uniquely identifies a tuple. So it says unique constraint field, and on R1A, the column A, right? So it does not insert over here. It can insert A2 B2, which is fine, but it won't insert A2 B1 again. So it fails again. So now you can do a select star from R1. Oh, sorry, R1. So A1 B1 is there, A2 B2 is there, and A3 B1 can also be there. Just to make sure that primary key is. So B, there are multiple entries for B, but there are always unique entries for A. That's the constraint. Now you can have primary key on multiple things. So let's say I create a table, create table S, say B varchar, C varchar, and then you have primary key B comma C. So what it says is the tuple BC will be a primary key. You can see the schema for S. Okay, and this is there. Then you can do insert into S values. B1, C1, right? So this gets inserted. You can do B1, C2. This will work, right? Because the tuple B and C together, they form a primary key, right? I guess this is clear to everyone. Like if it is not clear, like you can raise your hand and we can discuss about it further. Okay, nice. So you have B1 C2, then you can have B2 C1. Oh, sorry. B2 C1.
Sir, let's say for the R1 itself, if you want to add B as a primary key, if it's already existing, how do you do that?
So that comes to the DBMS, what DBMS provides you and what you do not provide. in SQLite, when you define the constraint, it should be at the creation time. You cannot modify the constraint later on. But
Okay.
if you use MySQL, then you can modify the constraint later on. So if you were to add primary key on B1, then it will first check whether the constraint is satisfied or not. If it is not satisfied, it will throw an error. It will say cannot assign primary key to B. But like the additional constraint that you are adding, if it is satisfied for all the entries, then it will add it and it will ensure it in the future as well.
Okay.
Okay. So this is the B3C1, B3C2, and B3C3. So you can do select star from S. So you see it's there. Now if that's pretty trivial. If you add B3C3 again, it will say unique constraint failed because the tuple together B and C, they form a primary key, right? So before we go into foreign key, there is a setting that you need to add, because then otherwise foreign key does not work over here. So this is a setting that you need to add. So you say pragma foreign key is on, so the constraint will be on in foreign key. Now let's say I create another table, create table rs, and the attributes are a varchar, c varchar, and you say foreign key. So sorry, my computer is a bit slow. It's acting a bit odd. Let me close some apps. Okay, foreign key on A. References are of A. That is something you can do, right? So when you insert into RS values, let's say if you do A4C1, will this work? If you have tried, like don't say, but if you have not tried, you can speak if this work or not.
No,
Oh,
because A4 is not there in A table R, right?
my computer froze again. So I wanted to do an R1. On R1. Okay. And then so this won't work, right? Because A4 is not there. So it says foreign key constraint failed, right? But A1C1 will work. A1C2 will work also, right? So this also works. So if you do select star from RS, you see there are two entries and both of them work perfectly fine. You can also add a foreign key C that references S, and you can check that that also works. But for simplicity, I just added one. So that is something you can try it at home, right? So that's how you do implementation for primary keys and foreign keys, right? Now, let's
Sir, please explain foreign key again.
foreign key. So I'm saying that RS, right? Table RS, it has A as an attribute, and it's I am saying foreign key A, it references R1 of A, right? Is this clear till this part? Just
Yes,
give
sir.
me okay.
Yes, sir.
So what I'm saying is that any entries in table RS, the value for A, there should be an existing value in R1 as well. If you enter something in RS with some value of A, that should always exist in R1. So what do we have in R1? We have A1, B1, A2, B2, and A3, B1, right? So what all values for A do we have in R1? It's A1, A2, and A3, right? Give me any yes or no. Like,
yes,
so that
sir.
so
Yes,
this
sir.
part is right. So what I'm saying is when I insert into value R1, A4 and C1, right? In the constraint, I said that A is a foreign key which references R1 of A. And A4, it is not present in A1. So only A1, A2, A3 is present. A4 is not present in R1, right? Is that clear?
Yeah.
So when I say insert into RS value A4 C1, it says foreign key constraint failed. Does that make sense?
Yes, sir.
But A1 is present, right? A1 is present in R1, so it passes. Also, if I do A2, that is also present in R1, so foreign key constraint is satisfied, so this will also pass. A3 is also present in R1, so that will also pass, right? Is this clear?
Yes, sir. I got it,
And,
sir. Got it. Please.
and you can add multiple times if you want.
Yeah.
So I said this will form a bag, so it will add it multiple times over here, which you can easily check. Any other question till now?
Sir,
Yeah.
sir. So in the primary key, what if I want two columns which should individually have unique values? Like, how should I define it then? Because right now we saw it collectively should, if there are two columns, it collectively should take individual unique value, right? What I can define, why can't I define two columns which should have individually unique values? Then how will I define it?
So if even if one column has a unique value, that's your primary key, right?
Okay.
Right. So you can just do primary key on that thing on one column only.
Okay.
But
yeah. But then if a user is putting,
yeah.
Continue.
So okay, I got your question. So you're saying that I want, but if you do primary key on both, then the tuple will be unique. So user can put multiple entries in one, right? That's what your question is.
Yes, sir. Yeah.
So there is a constraint called unique. You can add,
Okay.
and it ensures that everything is unique. So I don't remember the syntax for SQLite, but say S1 A varchar. I guess how this is how you define it. B varchar.
So what is this unique if you want only one primary?
Yes, the entry should always be unique. Insert into S1.
So then you can just choose unique for. Can you choose multiple columns also?
Yes, you can have multiple columns as unique. Okay, so it says unique constraint failed, right?
Okay.
So
Yes.
you can do multiple. Oh shoot. You can do H2 and you can also say varchar unique. So now individual columns will be unique. Oh, sorry. Now A2 B1 will fail. A1 B2 will also fail. Only A2 B2 will work. So in this case, both the individual columns are unique. So then the question arises, why do we need primary key? Right?
Yes, sir.
So primary key is essential in terms of indexing and searching. So that's another use case. We will look at indexing and searching when we go to like lecture 3 of database, lecture 3 or 4. That's when we will use that. But yeah. Any other question? We will come to that doubt later. So anything that you guys did not follow or think I should
So,
repeat on? Yeah.
so if we try to create another table with the same name which already exists, does it overwrite? Or like, how does it behave?
It will throw an error. So say I create this table, right? It says table already exists. And the way to view your table is dot table. So it shows all the table that you have over here. R, R1, RS,
So,
SS1, S1.
so sir, like is like if we want to create a table with the same name, we first need to delete the previous table.
Yes, you need to delete the previous table. The syntax for this, that will be drop table, the table name that you have over here.
Okay, sir.
And you know the table you want to delete. Okay.
Yes, thank you, sir.
Any other questions?
So, like, are there any specific scenarios wherein the usage of unique constraint would be useful, like in like when we do some real world any case scenario?
Yeah, it could be useful. I can't think anything from top of my head, but there could be scenarios where unique constraint could be useful.
Okay.
Right. Any other question? Any doubt on foreign key, primary key, referencing, creating table, deleting a table? So I guess one more thing to look at is, can I drop table R1? Will this work? Did you try it, Ashley, or?
Maybe sir, because it has a connection to some different table through a foreign key, so maybe it might not drop it.
Yeah, so it won't work. So it says foreign key constraint failed. So when you want to delete something, you need to ensure that everything will work. Like every other references, it gets deleted before you delete that. So first you need to delete RS, then you can delete R1, and then you can delete. Then only you can delete R1. How will we get population of Hyderabad in your previous example? We will come to that, Gordon. So that is part of relational algebra. That is the next topic that we are going to discuss, like what kind of operations that you can perform. Right. Any other question? So this one it's clear to everyone, right? Why this won't work? Drop table R1. Because so okay, cool. So let's talk about the relational algebra. So I won't use the whiteboard. I will just do it over here. So because these are pretty simple, and I guess doing a hands-on will also make sense. So way to comment on SQLite is used to use double arrow. Now we are going to talk about relational algebra. So there are like essentially 7 fundamental operators you can do. So relational algebra is a set algebra, and there are 7 fundamental operations that you can do in on the relations that you have, right? So let's look at the first one. First is the select relation, select one. So this is number 1. First operation is select. So what does select do? It does some kind of filtering. So we say that we define a predicate and on the relation. So over here, the input is a relation R and a predicate, and the output is, so let's do this. Output is filtering based on predicate.
Sir, could you scroll down a little? It is not visible from the bottom.
Now is it visible? What I wrote?
Sir.
Okay, so this part is clear, right? So for in relational algebra, we are talking about set algebra, and first relation that we are going to talk about is select. Select does a filtering operation. In what is the input? Input is one relation and then a predicate, and the output is filtering based on a predicate. Okay, so I will do this. Now it's clear, right? Okay. So that's there, right? So an input could be, so we have 2 tables, right? So let's say we have schema R1, right? This is a schema. So my input could be R1, which is a relation, a predicate. So I say a predicate could be like A is equal to A1. That's my predicate that I have. And then filtering will be like all the outputs that has A is equal to A1. That's the filtering operation that I have. Way to do this in SQLite is select, you do select star from R1 where A is equal to A1. So this part where you're adding the where clause, it's the filtering operation. So it gives you everything A1, B1. So the example that you said, the Hyderabad one, right? So you can do select star from population where city is equal to Hyderabad. This will work if we had that database. So it would have given you all the information. Does that make sense? Right now this will throw an error because this is not there, but yeah, by default it would have given you the information. Another thing is projection.
Sir, and how
Yes.
can we choose Hyderabad of India or Pakistan?
So you can have multiple filtering, right? You can do where city is Hyderabad and country is India. So it's very similar to if else logic, right? Or you can do city is Hyderabad and India, or you can say or country is Pakistan, right? So this also does the, so it will either match this or it will either match this part or will match this part, right? Or you can also do not equal to, things like that. So those are basic operations that you can do. So you can do country not equal to. So it's not exactly like this. The way we do it is country not like, and we say this. Whenever we do string operations, we do it like this, where city equal to or we can use city like Hyderabad, something like that. So there are multiple ways to do it. So I would encourage you to try it on your own. Say, create your own database population and add these things and try to work on these queries. I will copy this and give you guys. Let's move on. Is this clear to everyone? We will do just one more and then we will pause for the day and we'll continue the next day. Okay, since A from R1 is a function from RS can be insert. R1. So A1 we can insert it, but A is primary key, so we cannot insert like R1. A is primary key on R1. So primary key, the objective it's always unique. So number 2 is projection operation. That's the second relational operation that we'll use. So in projection operation, the input is relation R, and then you have subset of attributes, and then output would be another relation R prime. Let's say output is always a relation. So this is also a relation. When I do select star from this and I get this value, so this is also a relation. So when I say filtering based on predicate, this is some other relation that I get. So I can say select A from R1. So I'm saying that input is R1 and subset of attributes, so I'm saying only select A from R1. So that's the output. So there's a new relation R prime. It looks like that it has only one attribute and the values are A1, A2 and A3. So this is the projection operation. So say you create a table S2, create table S R3. No. I'm create table TC A varchar B varchar C varchar right, and insert into A1 B1 C1 then A2 B1 C1 right. So I can do select A comma B. So it's a set of attributes from T. So this is a subset of attributes and T, and this is the relation R prime that you get a new relation. I'll scroll this way. Right? You can do B comma C as well. You can do A comma C. So all these are subsets of attributes. You can only do A. So you get two outputs, so on and so forth. So is this clear to everyone? Like what? It's pretty simple, I would say. Instead of star, you're just putting the attribute. Okay, so I guess this will be it for today's lecture. I have a hard stop at 10 o'clock. It's morning 10 over here, so I need to go to other meetings. We will continue with this topic tomorrow and we will look at advanced SQL queries. Also, like if you have not downloaded the database, you have one more day to download it. Rahul, you raised your hand. Yes, what's your question? Or it was there by default. Rahul?
So it was raised long time ago. So yeah,
Oh,
talk to
sorry. So guys, please try to download that database. I will try to look for another alternative. I heard that the size is too huge, but Yeah. So please do give feedback via post so I can know like whether the pace is slow, fast, or it's right. And that will be it for today's lecture. Like if you have any doubts, you can tell me or we will stop it for today.